Yeah. So mainly my focus has been working my way through the uh oh,
Hmm.
sorry, I said it was like reconnecting. Um,
Oh,
I was spending most of my time doing the working through the Neat Code 150. And
sweet.
yeah, most of the problems I get after working through them, there's some that like there's one that I'm working through now that's kind of confusing me, at least the optimal solution.
Hmm.
It's oh, but it's funny, you know how you said there was this problem with like median of a data stream.
Oh,
Uh,
right.
that was Yeah, so actually what was interesting was I found that problem a lot easier to understand than the other median problem. The one
Oh,
with the uh because well, I mean I probably couldn't derive the solution on my own, but once I understood, so there was like a two heap solution, like it wasn't that hard to implement once I knew the approach,
hmm.
to have like a min heap and a max heap. So that's good. But yeah, so there are a couple that I was working through, but um, would so today would we want to do a coding question, or would you want to go over the questions I had? I'm not sure which you think would be more useful, but um,
Yeah, I think a bit of both would be great. As always,
yeah,
my goal is to help you. And from my session notes, I did have that we could focus on a bit of additional level setting and feedback for code.
okay,
But as always, I think it's always good to start with some, updates. You've provided some good updates on how
yeah.
you've been going through the Neat Code 150. Any other updates with respect to like interviews or top of mind?
Um, no, so I haven't had any interviews yet. I'm just kind of building my skills and everything, and I've been listening a lot to Ethan Evans, and the YouTube
Mm,
videos are really helpful, or they seem to provide good advice for general workplace things, and that's been interesting because it's easy to listen to while I'm doing other things. So I've
right.
been doing that. Um, and I have things on my to do list, like there's the Facebook ML thing. I just haven't gotten to that yet, but so I'm
Hmm.
doing what I can, do it as much as, but this between last time and this time, I really tried to hone in on working through more coding problems. So I can um, what's the word that was used? I don't remember where I heard it, but it's like don't bring a knife to a gunfight for interviews. So
Oh,
trying to work through these problems. Um, and it does get easier as I go. Some of the problems are still hard, but I think it's sort of like building a muscle, which is good. So
hmm, excellent. Yeah, I think that's great that while we level set just a few things and develop focus areas, yeah, in the meantime, if you can focus on those things, but also practice and go through things like the Ethan Evans videos. Those are great, and also some of the Facebook machine learning like field guide. And I
yeah.
don't know if I also recommended for ML system design the book by Alex Shu and what's
Oh, does he have one
the
about
co-author?
ML, or is that the in
Yeah,
general? Oh, okay.
yeah. So let me add that, and I'll be sure to write it as well, but
I
just so I don't forget.
I
Hmm.
did see that good because I'm part of Byte Go now, which like since it sends out, you know, I think it sends out like two or three things a week, which is good
Hmm.
to like keep me non-rusty on those things. But I think there's something on that site that lists ML system designs. I wonder if that's based on the book too. But either way, it's good to have everything that I can. So um,
Absolutely.
yeah,
Yeah, and my experience on their website is there's pretty good overlap actually between the paperback ML System Design interview book. So either one is good,
yeah,
and
yeah,
it's really good to practice because they go into a lot of back of envelope calculations that influence the design. So that's always helpful too.
Yeah,
Cool.
definitely.
Okay. Before we get started on code, any other questions or updates?
No questions that would take less than 15 minutes probably to go over. So
Okay.
I'll hold off for now.
Okay. Cool. So, yeah, in that case, let's go over one of the problems I have for today.
Okay.
And yeah, and we can get started. So I'll paste it in, let's see, here at the top, starting around line 8.
Okay. All right, I see. Okay, so given an n by n binary matrix grid, return the length of the shortest clear path in the matrix. If there is no clear path, return. A clear path is a path from the top left cell to the bottom right cell. Okay, such that all the visited cells of the path are 0. All the adjacent cells are 8 directionally connected, i.e. they're different and they share an edge or a corner. All right, so let me think about this. So 1, 2, 3, 4, 5. Oh, I see. Okay. So I get what 8 directional means. Okay, so 8 directionally connected, and the length of a clear path is the number of visited cells. I see. Okay, so if so actually give some examples. So if we look at example 1, so we start at this 0, and if we want to go from here to the bottom right, then so we start here, we can go to the right twice and down twice, which makes the length 4, because we want to only pass zeros. And if we encounter a 1, that's illegal. So I understand that example, and then this example down here. So this, let's see. So there's no output, but if I reason through it, then let's see. This one we actually, is it even possible on this one? It looks like it's not. So if we try to go down, we're trapped. If we try to go down and right, we're trapped. And it doesn't say anything about being able to like wrap around. Like if we go off to the left, it won't go back to the right. So I believe we're trapped on that example. Is that correct?
Yeah, exactly. That's right. So that's in this example where we would output -1.
Yeah. So anyway, so if I'm like just thinking about this problem, so the idea is all of the adjacent neighbors, whether it be right, left, up, down, or diagonals, which there are calculations for those. You can, but I think the idea of this problem will be to implement some sort of breadth first search, because that makes sense for doing things with neighbors, and that could be implemented by using like a queue. So let me just think through how we can apply that here. So it's like we start at, let's say we look at the example where it works. So we start at this 0, we'll get its neighbors, and then for any neighbor that's a 1, we just stop breadth first searching that particular path. But if it's a 0, then we can recursively breadth first search, or iteratively breadth first search a path with a 0, and then we can keep doing that until, well, so let's see. So let me think about first the case where, let's think about a case where we get stuck. So how do we know that we're stuck? So we know that we're stuck if we, I think so. We're stuck if we empty the queue of breadth first search, um, but haven't gotten to the bottom right, or at least that's my thought right now. Maybe as I flesh this out more, it'll change. But that's my first thought, um, and then of course the other way it would just continue at the queue, but then if we get to the bottom right and it's a 0, then then we've won. So in terms of the shortest, okay, so that covers getting stuck versus being able to clear it. But now the question is, how do we get the length of the shortest? So there could be many different paths, and through breadth first search. So how can we keep track of? So if we start from the upper left, and so if we do things adjacent to that, so if in our recursive function we would have to keep a parameter for, I guess, like which, like whether we're on, whether we have one level of neighbors, two level of neighbors, so on and so forth, so that when we get to the end, it'll tell us. And then, so wait, so returns an integer, so with the length. Okay, so we don't actually need the path itself, we just need the length of the shortest. And actually, I think, and this may flesh out in the implementation, but I think breadth first search, I think it gets you the shortest on its own, if I recall. But I don't remember the proof for that, but I'm pretty sure that just by implementing breadth first search, I think that alone will return the shortest. Okay. All right. So anyway, so I think I have enough of the design to start some code here. So let's make a okay, so our main function, so it'll take in, let's call it shortest clear path. Okay. And it'll return an int for the length, and it'll return -1 if it's bad, so it'll return an int. It'll take in a two-dimensional grid. So so in Java, that could just be, I guess, double int array.
Exactly.
For grid. Okay, so there are a couple little coding things that I'll have to think about here. So getting the neighbors right. So, so let's see. So we take in the grid. Is there anything else we have to take in off the bat? I don't think so. Okay. So, all right. So what we'll do is, okay, so we're going to need a helper function too. So let's call it BFS. And I think, I'll have to see what it'll return, but maybe that it'll also return an int, but it'll have to take in the grid. It'll have to take in, so the level that it's on. So like, if we're at like the neighbor of the upper left or the neighbor of its neighbor and so on and so forth. Okay, is there anything else? I think that might be good for now.
Okay, and let me ask a brief question here. So yeah. I think there is a way to implement BFS with recursion, right? So that if you're thinking about maybe repeatedly calling your helper method BFS, I think there's a way. But I think you mentioned
a queue.
Right, and we
Yeah.
can go that way, but yeah, if you're thinking of
Oh, yeah.
DFS with a queue, right?
Yes.
The minor hint I'll provide, or two minor hints, is one, right? We want to initialize our queue at a
Yep.
special place,
Mhm.
and while the queue is not empty, we can do something basically iteratively.
Yes. Yeah, and I've seen code like that too. So that, yeah, I don't know why I even put, yeah. So I guess, yeah, DFS is usually the recursive one. So, okay, so
Mm-hmm.
here, so we make a queue. Okay, so what will this queue actually hold? So, we want to queue the, um, well, probably the coordinate would be the most helpful because, zeros and ones are all over the place. So the distinguishing factor is where it's located. So let us do single int array
Mm-hmm.
equals new linked list. Okay. Um, okay, so we're going to start it at, so a couple things. Can we have, I assume we could be passed in an empty grid, right? That's an easy case to cover, so I can just do it. So if grid dot length equals 0. Oh, well, actually, that's a good question to ask. So what do we want to
Mm-hmm.
do if it's empty? Is that considered no clear path or?
Yeah, that's a great question. So let's briefly cover pros and cons of returning -1 versus returning some exception.
Mhm.
Which of those two do you think might be better in like a production environment?
Well, so I'm just thinking, so in the context of the problem, so it has to tell us whether there's a path. So if we have an
Mm-hmm.
empty grid, I don't see a harm in returning -1 because like we didn't get past anything. It depends what the caller would want to do with it. Um, so I don't think necessarily us throwing an exception off the bat is necessary. Um,
Mm-hmm.
but I mean, I could go either. Like if you had a weapon to my head, I'd probably just return -1. But if you think there's a better
Yeah.
option, I could do that. Um, so.
Yeah, and -1 also makes sense if we are almost pedantic, if you will, and say a clear path is only when there's a 0 in top left and a 0 at the bottom right that we can get to, right? So if it's an empty
Yeah.
grid,
Yeah.
there's no zeros, and so -1
Yep.
makes sense. Okay, cool.
Okay. All right. So we got that out of the way. And so another like coding thing I know is helpful for these. So we have int rows equals grid dot length, int calls equals grid 0 dot length. I just remember that from some practice problems I've done. Okay. So we got that. So we have rows and columns. Okay. So what specifically? So basically what we'll be doing, so like we start at, so do we just kind of want to loop through this and get neighbors? Well, okay, so another thing we'll have to do is we don't, let's see, can we visit something more than once? So if we have, so we have this, we can, so let me think about this. Well, so within a given starting node, you can't. Like, so if you're at level 0, then you don't want to visit something more than once. But if, if there's another 0 down here, then maybe you could visit that same node again. So you can't have a global visited queue, but maybe within a given place. Okay, so I have a thought. So I think this is what you're getting at with your hint. So if we start down here, we could say queue dot add new int 0, 0. So we can start by adding that, and then oh wait, what did I do wrong? Oh, nothing. Okay. All right. So what we want to do, so it's talking about while the queue's not empty, but let me think if we, so we want to iterate through. Okay. So I think I have an idea. So if we have for int I equals 0, I is less than rows I plus plus, and then for int j equals 0, j is less than calls j plus plus. So this will be going through all the coordinates. So we start at 0. We want to perform breadth first search. So what we want to do here, so while not q dot is empty. Okay. So we want to get its neighbors. Okay, so that's one coding thing to think about. So the left will be like x minus 1, and then right will be x plus 1, y will be the second coordinate plus 1, and so let us do. All right, so let's see. Well, first we need to get the current. So int cur cord equals q dot poll, and then okay, so now what was there's definitely a strategy to cover this. I think it was I think I might remember this. Okay, so let's have another let's have a double integer array that tells us how to get neighbors. So neighbors, and actually this could be global, so I might move it there, but
yeah.
So, but for now, let's see. So we want 1 0 1 1. Well, actually, wait. So 1 1 will be. Oh yeah, diagonal. Okay, so yeah, 1. Okay, so sorry. So 1 0 0 1. Oh, and then we want the minuses. So -1 0. Actually, I feel like I could loopify this. What do you think? Because at the end of the day, so are all negative 1 0 1 negative 1 0 1. I mean, we don't need to check 0 0 because that's the same coordinate. But for the other ones, so I guess what we can do. Well, so let's see. So how many? So we're looking at 8 neighbors. So let's do this first. So let's just make a new. Sec. Oh, it's 8. It's 8 by 2. Okay, so it's 8 by 2. And let's get this global because we only need it once. Let's do it here. Okay, so I have that right there. Okay, so how do we want to? So if we loop over. Wait, so sorry, is it 8 by 2. Okay, so to populate that for int I is 0, I is less than neighbors dot length So, okay, so you want to populate this because we want to have like -1, 0, but so we say if I doesn't equal 0, or sorry, hold on, let's say that. If I and j don't both equal 0, so if not I equals 0 and j equals 0, then we want to populate it. So so neighbors ij okay, so it's -1. Oh, I should.
Yeah.
Oh.
Yeah,
no,
on the right. Yeah, I think you're on the right track here, but just in the interest of time, because you did articulate what you want to do here, let me throw in this.
Okay.
And,
yeah, I should probably have that.
Yeah. Oh no, all good. So yeah, let's just assume that goes through fine.
Okay, great. Thank you.
And I might have done something wrong because it doesn't. Oh yeah, maybe just this part.
Oops. Thanks. Yeah, perfect.
Okay.
Okay, thank you very much. All right.
Cool.
Yeah. Okay, so that's that. All right, thank you. So okay, so all the queue is empty. Okay, so we got the current coordinate, right? And then okay, so we get its neighbors by. So let's see if we iterate through this. So like if we have neighbors 0, and then we get current coordinate. Okay, I see. So for int array neighbor in neighbors, so okay, wait, so let's see, curcord 0 plus neighbors, or sorry, plus nb0. Let's see, this is kind of pseudocode at the moment. Curcord 1 plus nb1. Okay, so
yeah, so you have like a new x coordinate and a new
y
coordinate.
Yeah. I'm just silly coding thing, but okay. So for it, just thinking about so yeah, because we're gonna have 8 of these neighbors, and let's see, I was thinking well, so we're gonna want the new coordinates, let's say cur neighbors So, all right. So current neighbors. Zero. Wait. No. So the row will be I. Current neighbors I 0 equals chord 0. Okay. Sorry, it took a while. And then, okay, so current neighbors, and then current neighbors I1 equals similar thing, but with ones. Oops. Oh, let's see. Okay. Yeah, there we go. Okay. All right. So we have, okay, so the current neighbors are all populated. So what we want to do with that is, let's do I plus plus. So once we have the neighbors, we want to say, we want to queue, let's see, do we want to check anything before we queue the neighbor? So we want to say, I think for now we don't have to. So I think we could just say queue, let's see, queue dot add cur. Well, wait, it's a queue of
pairs, right?
Yes. Okay, so it'll be, well, we could do, I think we do as a shortcut, q dot add all current neighbors. I think that'll work.
Okay, so let me give a hint here is suppose that we, well, let me ask this way, right? So as we're exploring the layers of this queue, you mentioned two important things in the beginning. One is we want to proceed, right, if one of the neighbors satisfies two conditions, right? A new neighbor that we're about to explore.
Yeah, so it has to be a 0. Yep. Yeah, so it has to, so so that's one thing. So it has to be a 0, and it has to, so it has to be not visited within what we're currently looking at. So I guess within the while loop. Okay, so.
So my hint is, before we add everything to the queue, maybe let's check one neighbor to visit, or one potential neighbor to visit, one at a time, right? So if we did something like, right, because we want to be careful about how big our queue gets. And so my hint is, what can we do with this new X and new Y?
Bound checking. So we can, so basically it has to be between, well, okay, so X has to be between 0 and, has to be less than rows. Less than calls. And then the Y has to be, okay, so if, well, okay, so if it's out of bounds, then what do we want to do? Then we want to just skip, I think. Okay, so if new X is less than 0, or new X is greater than, let's see, it will be greater than or equal to M. Let me see. Greater than or equal to calls. So it'll be greater than or equal to, or new Y is less than 0, or new y is greater than or equal to rows. So that's the bounds check. Okay, so if that's true, then I think we'll want to just
And one more condition, right? Like, what if new x and new y represents a coordinate in the matrix where we have a 1?
Oh, yes. Oh, also, I think, let's see, I have an issue here, so I need to, so we don't want it to be within, so because populating the neighbors, I think we want to close it here. Okay. So, wait. All right, so I'm going to get rid of this for now. Okay, so, right. So if this, then we want to continue. Okay, and okay, so the other thing we were saying was we want to check the value. So we want to go through the neighbors one by one. Oh, so that's why. Well, no, this will just populate. Oh, actually, I think I might. Record 0 plus NB 0. Oh, okay, so maybe, okay, so I think this could be useful to have it. Right, so if, I know what to do. So if grid new x new y equals 1, then we don't want to queue that up. So,
yep.
Well, it's actually, okay, so what's probably better is, so instead of doing a not, let's do the good condition. So if it's 0, then we want to add it to the queue. So queue dot add, let's see, new int. So this will be the the new x and new y. Okay, new x, new y. Okay. So let me think if there's any other. Okay, so we did bounds checking. If it's 0, we want to add it. But so I'm thinking, is there a situation where, because I'm just, okay, so this, so we're going to queue up, because the situation I'm worried about is if, like if let's say our main node is the second 0 here, then we're allowed to queue up that third 0. Like if we start it here, so we only need the visited condition, we just need within, so I guess, well, one option is what I could do is I could, on the next iteration of the while loop, I could always clear the visited, whatever data structure, like a Boolean, actually here, yeah, let's do that. So, okay, so let me make a Boolean, well, so hold on a second, it'll be, so it'll be a Boolean for each coordinate, so that will be, right, so it'll be visited equals new Boolean grid dot length grid 0 dot length. Okay. So we have this visited thing. So what this will have is whether that's been visited, and by default, Booleans are always false, so that's good. So before we add it to the queue, we want to say, so if that and not visited, and I'll just copy this. Okay. All right. That's good. Okay. And then we're going to have to mark it as, so once we add it to the queue, then we're going to want to say that this is true, so we don't do it again.
Exactly.
Okay. Okay. So now, actually, hold on. Okay. All right. So now, what we'll want to do is we want to clear. So if we get to the end of the while loop, we're going to want to clear that visited, because when we get to a new node, because, okay, so there are a couple of things. There's that visited, and then I still haven't implemented the leveling yet. So if we, so if we're at, like this, if we started this first, so we're at the second node, that's one away. So we need to have some sort of counter too. So I'll put that in. But okay, but in the meantime, so what we could do is at the end of the while loop, or actually at the beginning. We could do it at the beginning. So so at the beginning. Hold on. Oh, I can just do it up here. So, because we already have an I and J. So visited IJ equals false. Okay.
Okay.
Yeah.
So let me offer two more hints.
Okay.
To close.
Yeah.
So first hint is on something we mentioned very briefly though in the beginning is, do we need to visit a node more than once?
Oh, I see. So, okay. So if we have, I think the answer is no. I'm trying to reason out how we track that. So, like, if from the second node we have the third, then we don't really, as long as we know the level relative to. So, like, yeah, if we started this second one, we know that this third one is one level away. If we're at this top left, we know that's two levels away. But we would still. Oh, but let's see. Do we even need to necessarily know? I guess. Let's see, does it matter? Maybe it doesn't. Yeah, I think I see where this is going. So actually, yeah, I think. So I'm not gonna bother with this. I'll comment it out in case I don't think I need to bring it back. Okay, so we mark it as visited, have this. Okay, so now the level. So how do we want to keep track of the level? So basically, once we visit a neighbor and mark it as visited, we want to. Well, no. So it's not a global counter because it's relative to. Oh, hold on. So. Okay, so if we're looking at the immediate neighbors, that's level 1. And then okay, immediate neighbors level. So let's see, and maybe is it every time we enter this while loop? Let me think about that.
Yeah.
So yeah. So upper left, we're queuing up the neighbors, level 1. Then we look at, so the next thing in the queue will be a neighbor, then that will be level 2. Okay, yeah. That's nice and simple. Okay, so int level equals 0, and then level plus plus. Okay, so what we want to do with that is, so basically, so when we go through this, let's see, oh wait. Oh yeah, so I did my q.poll, so I remove it. So once this is empty, return level? Let's see. Let's see. So I may need to clean up some of this code, but I think the approach is pretty solid. Okay, so let me run through what I have. So we have our visited, we have our queue. If the grid is empty, return. Okay, so I need to cover. So if the path isn't found, okay, yeah. So I haven't covered that yet.
Right.
So how do we know if we get stuck? So hold on. So if the bottom right hasn't been visited and the queue is empty, then we're stuck. Yep. So what we want to do is if not visited, so this will be so it'll just be rows -1, calls -1, rows -1, -1, calls -1, then return -1. Yep. And then otherwise it's fine. We've cleared. Okay, so that's good. All right, so let me resume running through. So we have our rows and columns, the neighbors, which thank you for that. So we have our level starts at 0. So we start by adding 0, 0. Okay, yeah. One little thing I did not do is I need to say, or actually, hold on. So I need to mark. I need to mark 0 as visited. So let me just do that. 0, 0 equals true. Okay. All right. So get rid of this. Okay. So the queue is not empty. Increment the level. Well, so actually, wait a second. This won't quite work because let's see. So let's say we're at the first neighbor. We increment the level is level 1, and then we get to the second neighbor. Oh no, but wait. But it's queuing up its immediate neighbors. But then we have to bring the level back. Oh no, but it's only visited once. So this isn't quite. Because what did I just do? So I see an issue here because this is just literally everything that comes out of the queue. It's incrementing the level. That's not quite what I want because I want all the immediate neighbors to have level 1, non have level 2. So it's close. I just need to think about how to count for that.
Right. So, okay. So we are at the 40-minute mark of this problem, roughly speaking.
Yeah.
So I think it's a good stopping point.
Okay.
And so let me start. Well, traditionally, if you're comfortable with it, let me ask you if in a minute or two you might describe how you felt about this problem.
I felt like if I got to the graphing section of the practice, I probably would have done a lot better on this. I just haven't gotten there yet. Um,
Okay.
but I mean, the problem seems in line with with what I would expect for a BFS problem.
Mhm.
I just haven't really practiced that kind of problems. I didn't know the neighbors array and stuff like that, or I didn't remember how to do that. But overall, like I felt like I knew the approach. There were just some aspects of coding it up that confused me in the moment. So,
Mhm.
uh,
Yeah. Oh, sorry. Go ahead if I interrupted.
no, that's pretty much it.
Cool. Yeah. So by and large, I would agree. Like the hot, two pieces of good news, if you will, that I would say. One is compared with last time, I feel your intuition for finding an algorithm that will solve the problem is a lot better and faster, right? This problem is also tricky. I mean, the graph setup is a little given to you, if you will, but it is non-trivial, at least in my opinion, to say, okay, do I want to do this BFS, DFS? You can actually do it both,
Mm-hmm.
but to really articulate why you might want to choose one of those. And I think you did a really good job there, especially in the beginning, right? You said, hey, let me
Mm-hmm.
consider both. And yeah, I think BFS will be good because I can go through layer by layer, so to speak. So that
Mm-hmm.
was really positive. And also good news in general, I would say, is it's also informative that you mentioned you haven't gotten to the neat code graph section
Yeah.
because I think with this problem as a baseline, once you get to that section, I think two things will happen. One, you'll realize that your intuition is quite good, and it's just some of the finer points that those practice problems and maybe one or two more sessions will help with. So
Mm-hmm.
that's really good news, right? Like if you had said, "Oh,
Yeah.
I went through all of the graphs on Neat Code 150 and I'm still getting set," that's okay too, but you have like a head start there. So that's
Yeah.
great.
Yeah.
Um, Also, what I really liked is your clarifying questions, right? Like, what does it mean to be eight directional? And you did a really good job there. You said basically, I'm going to assume it means diagonals, up, left, right, down,
Yeah.
and got buy-in for that. So that was great. And
Mm-hmm.
also, you considered the edge case, like, what if this thing is empty? Should we return
Yeah.
-1?
Mm-hmm.
Um, Also, the overall syntax that you're using is quite good. Like it's pretty obvious, right? Like you know how
Mm-hmm.
to manage and work with queues in Java, so that is all plus signs there. And overall, like your solution strategy, I would say the building blocks are there,
Mm-hmm.
which is great. Now, in terms of the potential areas of improvement, I like to call them, is just a little bit more practice with BFS, and maybe looking at the videos too from NeetCode will help you gain intuition on what actually are the layers that I'm exploring in this setup. Because once you get that intuition, then basically you'll notice that a good idea is within the while loop, right before you do neighbors,
Mm-hmm.
you'll want to do something like, how should I call it? Let's say, oops, my scrolling. 1 second. Yeah, something like um, queue size is, or if you want layer size,
Mm-hmm.
right, is, oh, it, uh, queue, sorry, what were we calling it? Yeah, just queue dot
Yeah.
size.
Yeah.
And now, once you have that layer size, then you'll gain intuition and say, okay, I want to update my answer. This means that the thing is not empty. I'm going to keep adding or traversing this level. But now comes the traversal part.
Yeah.
So for the traversal part, here's where you do something like int I0 while I is less than layer size.
Mm-hmm.
And I plus plus. And that's when you would start right after you do this, right? Because you're indicating, I know the
Ah,
size of my
yes.
current layer. Now I'm going to explore neighbors. And so that's one thing. And also, if you ever feel like you're running short on time, just do a little check on what's the time and space. Because I think if you'd considered time and space, you've
Hmm.
got basically, so to speak, three nested for loops, right? You've got your for
Hmm.
loop on line 74, 75, and 76. So when you start seeing something that's quadratic for graph, generally that's
Yeah.
okay, right? There's like a quadratic number of uh, things to touch or number of nodes.
Yeah.
But this while loop starts getting us into the potentially cubic case, right?
Hmm.
So once you start thinking like, ooh, I might start getting cubic, then I think you would have seen that actually you don't need these um, for loops on the
Ah.
coordinates. And I
Hmm.
don't know if it'll let me tab over, but basically that's like the pattern of BFF is I
Hmm.
have my while queue, I
Yep.
have my for loop for layers, and within each layer, I am going to explore and make a condition as to whether I want to add or not.
I
So,
see. Yeah.
right, yeah. So technically, in the while loop, we do have two, or a nested for loop, if you will. Right, we'll have this for loop on line 81, and we'll also have within inside of it. This is going to be ugly, but I'll just do it.
It's fine.
A for loop inside. And the tricky part here is to think like, what's going to be the time and space? Well, it's actually going to be constant time inside of this for loop because the number of directions is fixed.
Okay.
And yeah, the main cost is really in this top while loop. Why is that? Because the maximal size our Q can be is everything, right? We just
Yep.
end up touching everything, but we also do two short circuits. One short circuit is here, right,
Hmm.
on line 94, right, is I don't want to grow my current layer if
Right.
the neighbor I'm considering is already visited and it
Yep.
satisfies these conditions. The other short circuit, and something that'll come with pattern recognition in queues, is what's my terminating condition?
Hmm.
And so for that, actually, you can put a terminating condition at the top. So you pull it here. Okay, good. And now what we want to do is to say, what can I say about a terminating condition and my current coordinate? Well, before I even explore, the terminating condition could be something here like if current coordinate oops, equals row, if I've gotten to the end, right? Minus
Mm.
1
Yep.
and current coordinate equals, oh, sorry, you call it rows and
In calls, yeah.
calls. Yeah. Then what does it mean to terminate? Here's where I would do return level.
Got it.
Because now, right, I don't need to explore neighbors. There's no more to explore really, but I've gotten
That's true.
to a good, well, in a greedy way. There's a nuance to this, but basically we also need to argue that how do I know it's the shortest? I'm kind of doing it greedy because as soon as I get to the terminal point, then I'm going to return level rather than trying to go back up and add stuff.
Yeah.
Which means if we manage to not get to our goal or terminating point, then it basically suffices to just return -1.
Ah.
So
Yep.
yeah.
Makes sense.
And what else did I want to mention? Okay, so those are the main points. Yeah, I think if we were to do this again or a similar problem after you practice, I think you would knock it out of the park with
Hmm.
some neat code and maybe one or session or more, because I really do feel like the building blocks are there.
Yeah.
And just as a bonus, right? Like assuming you had the solution, one bonus thing that you can do if you have time is to add some insights that you know about Java on queues. And so one of them, just to think about, and I'll throw it out there,
Mhm.
is when you want to use queue.add versus queue.offer.
Mm. Oh, are you asking me? Because I think I actually know the difference, like in terms of at least the
Yeah.
definition. But um,
Mhm.
isn't isn't offer if you want to not have an exception thrown when, like, I thought if you try to do add and you try to do that, you try to add like a null thing, you'll throw an exception. But offer, I don't remember what happens, but I think offer will not throw an exception. That's what I know the difference to be, but I could be missing something.
Yeah. Yeah, that's essentially it, is they differ on the basically fail throw or fail exception, if you will, when you're trying to insert.
Hmm.
And, whether basically it's the space, or sorry, the set of conditions where you want to throw versus just returning false.
Yep.
And
Oh,
that
okay.
kind of stuff is, yeah, that kind of stuff is nice to add if you've had time to finish
Hmm.
the problem. And um, yeah, okay, so that's my general feedback. I really like this problem because to me, it's not like hard in the sense of saying, okay, I know I want to do BFS, but there's so many little details that it's a really good one to practice, at least in my opinion, with
Yeah.
respect to a timed interview. Um, cool. So that's my high level feedback. Any questions?
Um, so, well, I actually have a couple not related to this problem, but one question I have is, do you know if there's any, so I've both seen and experienced the idea that, like, if you get really stuck on a problem and then like you come back to it a week or two later and sometimes it clicks, like, do you know if there's any science
Mm-hmm.
behind that, like why that would happen? Or because it seems really, unless you practice it over and over, like for example, the the meet or the first median problem that I found really difficult, like I actually sketched out every step on a whiteboard, and the day that I did that, like I still was pretty confused, but then
Mm-hmm.
like I came back to it a day and a half later, and I was like, oh, like suddenly the visuals clicked. Yeah, I don't know if there's any like reason for that, or just sort of spaced repetition has just been shown to work, and I don't know, but yeah, I don't know if you know anything about that.
I haven't studied the science on it, but I do have some experience on exactly what you said. Like the first time I encountered this problem, to be fair, it was while I was practicing graph problems. I got to it and I just remember like struggling a bit, and it took me some time, but I got it. And then about a week later, I thought, okay, I've done so many other problems. Let me see if I can revisit some of the ones that I found tricky.
Yeah.
And a lot of things just like clicked when I revisited the problem. So I would encourage that overall. The
Hmm.
thing I usually suggest to avoid is like overfitting, so to speak, to say, um, I'm going to try this problem so that I can solve it in like 10 or 15 minutes, which is possible with practice, but then it starts feeling like memorization a little bit.
Yeah. Yeah.
So that's why I like putting a little bit of um, time between a problem and doing some others, and then kind of coming back to one.
Hmm. Yeah, and then so my other question, which may or may not apply tomorrow in a couple of days if spaced repetition works super well, but um, I spent at least like a day to a day and a half trying to understand the solution to let me get the problem number. It's called subset with duplicates, um, or sorry, without duplicates.
Mm-hmm.
Um,
Mm-hmm.
because so the problem, oh, subsets too. So the problem, like the pretty easy problem for backtracking was if all the elements are unique and you're trying to get the subset, you just combine the first element with the subset of the rest of the elements. But but I've
Mhm.
been struggling a lot with it's a problem 90. So, I mean, yeah, right now, like I've been stepping through the solution, like drawing it out, and I am at the moment, I'm still having trouble like understanding, like, well, first of all, how someone would come up with that in an interview, but also like
Mhm.
why it's doing what it's doing. So I guess maybe if I'm still stuck on it next, or well, okay, two questions. One is, do you think that problem is important enough to go over it if I don't understand it? Um, like, or just, forget about it. And then the other question is, um, like, do you think it'd be worth going over if I still don't understand it, next time or something? Cause that's pretty much, I think it's the only problem where I've actually like sketched it out step by step, and I still don't really get like why it's doing what it's
Mhm.
doing. Like most of the other ones, either like once I know the approach, I can code it up, or once I like step through it, I can usually get it. But that one, I'm just having a lot of trouble because of the aspect that you can't have the duplicate elements, and it makes the
Mhm.
code harder to understand for me at least. So I don't know. Yeah.
Right.
Do you think that problem would be worth going over if I still don't understand, or just kind of move on and get as many other problems as I can? Um, I don't know.
I would, yeah, I would say in terms of priorities, the first thing I think would be good to do is the first, what is it, 1, 2, 3, 4, 5, 6, 7, 10, 11 sections of the neat code 150. So that's
Yeah.
starting from arrays and hashing
Mhm.
and ending at graphs. And to your point, backtracking does happen there. So after we go through, or you feel comfortable more precisely with the majority of
Mm.
those sections, then we can say like, okay, maybe you're at a point where you feel like you've got graphs down, like DFS is cool, like
Mhm.
trees, you've got the different methods there and can articulate like, are you doing it in order, post order, or pre-order DFS? And
Yep.
same thing with arrays, like you know what to store, etc. Then we can say like, okay, cool. Now where did we have the most questions remaining? And it could be on
Mm.
backtracking.
Yeah.
Now, the second thing I would say though, like, okay, how important is backtracking compared with the rest of the 10 sections there? I would say, I mean, it's like a second or third priority. The main things actually I would say that you really want to feel super comfortable with are sections 1, 2, 3 being arrays, hashing, two
Yep.
pointers second, third
Mhm.
sliding window, and trees and graphs. Those five just come up so often and they set the stage for a lot of things that I would make sure if we're in a time crunch, we prioritize
Mm.
mastery, if you will, on those five sections.
I see.
And then say, okay, let's deep dive into other stuff. So that's the general advice. Now, super specific practical though, like if you're applying to a company that has a bunch of leak code problems
Yeah.
tagged,
Mhm.
that's another way to prioritize. So companies like Meta and Google are pretty heavy on graphs and trees. And to
Mhm.
be fair, backtracking does come up sometimes, but not as often. So that's another way you could prioritize.
Mm. Okay. All right. So it sounds like what you're suggesting is like maybe keep practicing different kinds of problems, and
Hmm.
maybe if I think I've covered as much ground as I can, then if there are ones I'm still struggling with, then maybe can go through it. But I guess so. My other question is for future sessions, especially if we're focusing
Hmm.
on coding. Like, does it tend to work better if does it tend to work better if I just like practice as much code as I can, you know, get, for however many days I need to and such, and then come back when I feel more comfortable, or do you think it's better to sort of force myself, like, okay, so like we need to have a mentor session in,
Mhm.
5 days or less. I need to practice as much as I can in those 5 days. Um, like, I don't know, what do you think tends to work better? Like, if I can keep myself accountable, so I just like practice as much as I can, and then
Mhm.
come back when I've practiced a lot, because I don't have any interviews on the pipeline, so I right now I have time to like go off and practice for however long it takes me. I just don't know if you've seen like people fall off the bandwagon if they don't have a
Mhm.
mentorship session in a little while. I don't know. Like, what's your experience with that?
Yeah, it really depends on your style of learning. Like my style is a bit of continuance and consistency. And what I'd like to try and do is say, okay, for the next 2 or 3 weeks, interviews or not, I'm going to do as much code as I can as
Hmm.
priority one. And when I'm feeling a little bit tired of code on a given day, I'm going to go to system design or behavioral practice.
Hmm.
Because for me, that consistency is pretty key rather than, saying this week I'm going to focus on code
Yeah.
and 4 weeks later I'm going to pause code and then maybe come back to it. Um, so,
Right.
so my advice for is to have, I would say, our next session in a time frame that you feel will be consistent, whether that's like a week or two.
Yeah.
And what we can do is we can aim for the next session, be it in a week or 2 or 3, whatever you're comfortable with, to be,
Yeah.
let's say, half coding
Yeah.
and half something else just to spot check and make sure we're
Yeah.
keeping up,
Hmm.
or full coding. So that's my general advice, is to make sure we
Yeah.
finish coding first before we start revisiting other areas.
Okay. Yeah. All right. So I guess, yeah. So I guess that'll be up to me, but you're saying if I can stay consistent, you don't see any downside with, like waiting a little bit to have another session. Because if, for example, today, like I mean, maybe I could have gotten it, but I just haven't practiced graphing yet. So, is it in
Hmm.
some ways better to come in, having practiced what I can, and then, if I don't get something, I know it's, some other issue than practicing.
That is one other way. Another way too to, you know, keep the consistency and to a degree accountability is if we could set up a timeline. So
Yeah.
in two parts, right? To say like, okay, by X date, you feel you'll get to, let's say, the first, or be done with, or gone through it, the first 4 sections, let's say,
Yeah.
arrays
Yep.
having 2 pointers, sliding window stack.
Hmm.
Then what I can do is probe those areas in our next
Yep.
session,
Hmm.
so that after the next session you say, okay, now we've probed enough in those first 4. Now let's say, how much time would you like for the next 3 or 4 sections, and just kind of do it iteratively. That would be my
I see.
suggestion, because
Hmm.
yeah, my goal with the first coding that we did on that funny or interesting lexicographic one and today's BFS was to do level setting and
Hmm.
baselines. And I think I have a pretty good idea now. So my suggestion would be to do a little bit more deep dive. So, for
Okay.
example, if you were to say, yeah, I've already gone through arrays, 2 pointers, and sliding, then I would
Yep.
say, cool. Then next week, let's practice on that. But if you were to
Oh,
say,
okay.
hey, I want another, X number of days or weeks to do those first 3 or 4 sections, totally fine, and we can wait for that.
Okay.
So
So
iterate
yeah.
deep dive.
So maybe, so I guess if that's a good approach, maybe what I could do is like say, because I have gone through several of the sections, but like maybe say like what focus on 3 or 4 of them, then maybe like you'll choose something from one of those to, and then check
Hmm.
on something like that. Would that be a good thing to do? You think?
Exactly. Yeah, I would say 3 or 4 sections
Yeah.
coverage at a time, and then we'll practice 1 or 2
Okay.
problems from each. Hmm.
Excellent. All right. Yeah, that sounds good. All right. Well, thank you, and yeah, I think that sounds good. Then yeah, and like you said, I'll try to. I mean, I kind of have been doing that in a way. Like if I'm burned out by doing too many coding problems, I like do system design or whatever, and I try to switch between.
Hmm.
Um, so it's been working too. So yes, I
Great.
appreciate the time and everything.
Excellent. Yeah, I would say keep it up. I've seen seeing improvements already, and let's proceed with that strategy of iterative deep dive on code when you're ready with the first 3 or 4 sections for our next one.
Hmm. Yeah.
And while you're doing that, when you say, "Hey, I just need a break today" or whatever for something else, yeah,
Yeah.
then behavioral and system design, so that when we get there, you'll be fresh on that too.
Yep. All right. Excellent. All right. Have a good rest of your day.
Uh, Thank you, Eric, and I will talk to you later. Have a good weekend.
You too. Bye.